screen here and share my screen. If ever I forget to do these things, then please remind me so that we have all of the information or all the lecture recorded on Zoom. Those of you just coming in, there's one more handout on the little podium-ish thing over there. It's another practice quiz for Wednesday. The quiz itself was already posted to GitHub, but the printer died, so I didn't get that printed last time, so you can have a copy of that if you would like. Most lectures, I'm going to start with, so this right here is Vim that I have opened up, and just a little outline of things for us to talk about today. This very first thing here, quick postmortem of the lab that we had on Friday. So one of the things that I noticed is that there were a number of people doing pre-lab work during the lab time. In general, I don't have a problem with that you should do whatever you think is most effective use of your time. But usually I try to have the pre-lab work structured so that it's probably not something that you're going to need to ask too many questions about. And the lab work itself is things that you might need to collaborate with other people on or ask questions about for me. And so I definitely recommend doing in the future, getting that pre-lab work done before the lab time. Also, ensure that you have pressed the watch button on the class repository, one of those pre-lab work things again. So here I have opened up the class repository in Firefox. So the CMC CSCI 046. And up here in this watch button right here, I can see that there's currently 53 people watching this course. One of those is me. But if we go on to the, well, I don't even need to go to the issues. I know that there's 60 people registered for this class. And so that means there are at least 8 people who haven't clicked the watch button up here on the repository. And that means as I post issues and announcements to this class, everything, all the announcements I post will be under this issues tab. If you haven't pressed this watch button, you're not going to get announcements emailed to you. And so you'll miss things about class. So if you would prefer to check the web page every day, then you're welcome to do that. But most people find watching the repository to be more efficient. So recommend do that. Again, the issues is for asking questions or posting updates about the class. And if you have questions, you should ask those questions in the main repository issues and not email me. I've tried, so there's been, I don't know, dozen or so emails that I've gotten over the past couple of days from students, and I've tried to respond to most of them. But in the future, I'm going to just tell you to post those things as issues to GitHub so that everybody has access to that information. The only exception to that, if it's like a particularly personal question about, say, for example, your grade and why your grade is a certain way, then that would be appropriate for email. But anything that's like, how do I do this? Or I'm getting this error message, or the Lambda server is not working, those would be more appropriate for issues in the main class repository. And here I'm emphasizing the main repository for this class because there's going to be something like 20 or 30 different repositories that we're going to end up using. The homework for this first week, if we, well, yeah, so click here and click here. This link right here is what's technically called a GitHub, or rather a Git submodule. And if you click this, and the URL up here is probably hard for you to read, but this part right here is something that you can hopefully see and make that a little bit bigger. But you notice that when I click this right here, the actual repository that I'm at is changing. So if I click homework right here, the repository changes to this new repository, this continuous integration repository. And if you post an issue here, which somebody has, then nobody except me is going to see this because nobody is watching this repository. So we'll answer this particular issue in class today. But in the future, you want to make sure that you're posting questions or announcements, anything to the main repository under the issues here so that everybody's able to see it. Question? Yeah, so the question is here under the watching, what thing should you click here? And you're welcome to click whatever you want. I recommend the all activity right here. The very first, this very first assignment, there was this under the pre-lab work, the meet and greet part right here, where everybody was posting individual things. And so you're getting a lot of maybe spam-ish email about all of this. And we're not going to have future assignments where everybody's posting an issue at a time. This is just to make sure that everybody is able to post an issue. So you're not going to get like 1,000 emails a week, but I do recommend doing the all activities so that anytime somebody posts something, you will be able to see what that message was posted. It's only this repository right here that you need to watch. The other repositories, like that homework repository, not things that you need to watch. Good question. Any other questions so far? Okay. So that leads us into a little bit about formatting those issues. And in particular, so this is what we call backtick in programming. It's one of the 3 types of quotation marks on the American keyboard. It's the one in the top left corner of your keyboard, right under the escape key. And coming back over here under this meet and greet thread, if I scroll down, this is the way that we want things to be formatted, or what I was expecting things to be formatted, where you have what's called a code block. And this uses the triple backticks right here. Most of these at the beginning, you're using this triple backtick correctly to post messages. And then eventually get to some where we're using the single backtick instead of the triple backtick. And if you use that, you'll see that you get the formatting is different, and it's especially when we start posting code here, it'll look really weird if you're using the single backtick to post things that are like a full line long. So in the future, pay close attention to the single versus the triple backtick. I'm going to be very picky about formatting things in our GitHub issues. And if you ask a question and things aren't formatted very nicely, then I will ask you to fix the formatting first. And the reason for that is that part of this class is learning technical material, but a major part of this class is also learning the sort of social institutions about programming and being able to interact with other programmers online effectively. And if you go over to somebody else's GitHub repository, doesn't matter who it is, if you have you can post on anybody's repository, ask anybody in the world who's programming, ask them questions about what they're doing. And if you use nicely formatted code, people will be likely to respond to you and give you helpful feedback. But if you don't, if your formatting or various other things is not sort of following standard conventions, then people will know that you are not a I guess, serious programmer, and so they will not spend their valuable time helping you. So I'm going to be picky about these sorts of things so that you can go on after this class and interact with people, and people will take you seriously. And just because I point out something that I think you could do a little bit better in your formatting, is certainly in no way like a negative comment on you as a person or your grade or anything. Yeah, so this sort of thing won't affect your grade at all, just trying to help you get into the programming culture here. Any questions about any of that? Anything administrative? Yes. Okay, we'll take a look at that one-on-one. Another announcement. So we have our quiz on Wednesday. We've covered all of the material for the quiz on Wednesday. Depending on how much time we use today, we may or may not do a little bit more review of that material. But the way the format of that will be of the quiz is that you will have 8 minutes at the beginning of class to complete the quiz. And I will be, if you would like more time on that quiz for whatever reason, I will be in class here about 16 minutes before the official start of class. And anybody who wants more time can come early and get that extra time. You'll notice here that I used the word 8 here and I used the word 16 here. All of the numbers that are going to appear in various places in the class will be powers of 2, that 2 for various reasons will be very important to us throughout the course, and to help get you like an intuitive sense of the number 2 and how magical it is with all its exponents. Every number that I give you is going to be formatted this way and not in like normal human speech. So this 2 in Python, you use star for exponents. So 2 raised to the 3rd is 8. So I have 8 minutes in class to complete the quiz, or 16 minutes I'll be here before class to give you more time. If you look at the quiz files themselves, here we go. You'll see that the total score, what the quiz is out of 4 points, 2 raised to the 2 power right here. All of your assignments, everything, anytime there's a number in this class, it's going to be a power of 2 like this. So that's, again, just to get you the intuitive sense of these very important numbers. If you have questions about specific material about the quiz, then I will be available after class to answer those questions. Again, you can post issues to GitHub, and we can work on them that way. Any questions about the quiz before we go on to today's actual material down here? Yes. Yeah, question A is about notes for the quiz, and the answer is that you are not only allowed, but strongly encouraged to bring notes, printed materials. The reason I printed out all these quizzes and things, even though they're available for you online, is so that you can write notes on them and have them available for you. And yeah, as you're taking the quiz, you can reference whatever notes that you want during the quiz. Feel free for all the practice quizzes to write the answers on them and have them available. All the cheat sheets, definitely recommend having those out in front of you. Anything that you want, as long as it does not require electricity to run. Okay, so today in class, we're going to finally talk about our syllabus 3 days into the class. And the reason that we're waiting this long to talk about it is that we're going to do it in a special way that's going to require the knowledge that you've got from the lab. And we're going to do something called a pull request to our syllabus to change exactly what is in the syllabus. So coming back, here we go, over here. Back button, back button. So I'm on the course webpage again right now in our course repository. Whoops, and let's go to the main page. And this first, so this readme.md file is what contains our syllabus, and it's getting displayed for us right down here. Again, my name, Mike is Bicky, but I prefer going by Mike. All of the things in this class, again, designed to help get you either more programming experience or more involved in programming culture. And in the programming world, the vast majority of people prefer to go by their first names and not by titles. But if you're going to Facebook, for example, nobody talks to Mr. Zuckerberg. They always talk to Mark. Nobody at Google, I'm trying to think of the founders' last names. I don't even, can't think of them off the top of my head, but Sergey and Larry, that's who people refer to. Microsoft, people talk about Bill or Bill Gates, but never Mr. Gates. So everybody goes by the first name. And to help get you into the practice of that, I go by my first name as well. The office hours, again, I still have a couple of meetings that I have to get scheduled, and so I don't know when the office hours will be scheduled yet, but I will post an issue when I have that, and if you are watching the repository, you will get the email about the office hours information. The QCL also started their operation this past yesterday, and so you'll have the QCL available to you all. And that information will get posted here to GitHub in a little bit. So quick fun facts about me. Grew up in San Clemente, pretty close here to Claremont. Spent 7 years in the Navy, nuclear submarine officer, worked at the National Security Agency, left as a conscientious objector. Happy to talk to people about any of these things. Worked at UC Riverside, close to here, taught in North Korea. Also happy to talk to people about that if you're curious. Well, I guess I'll say that this is part of a diplomatic exchange between the U.S. and North Korea to help improve diplomatic relations, having ordinary people from both of our countries interact with each other. We're actually going to see some material later on in this course that's related to that, and how computer science knowledge, programming knowledge is actually helping improve relations between these very hostile countries. And then the thing that's going to be most important for us in this class is that my wife is currently pregnant, baby due April 18th, which is 2 weeks before the end of the course. And I'm going to be taking 2 weeks off for paternity leave when the baby comes. So if the baby comes on time, then this would be like the last day that we have of actual instruction. If the baby comes early, then we will have this 2 weeks off period a little bit early, and then come back for a week or two of material after that. So I'll have to be a little bit flexible depending on how things go here. But the last, I don't know, month or so of the course's schedule will be up in the air based on this. In order to know about the course schedule and what we're going to be doing when, up here there's this future folder. And if you click that, here is the list of topics that we're going to be going over. Each one of these topics is going to take approximately 1 week worth of time. You don't need to look at any of these topics in advance. I will be moving them from this future folder out here as we need it. Only the things out here are the ones that you'll need to reference. But if you're just curious about high-level idea what we'll be talking about, it's there's the sort of outline of the course. It's a good time to pause. Any questions so far? Okay. So a little bit more about the course again. So the way I view CS40 or whatever intro course you took is how you work, how you program on your own computer, your own laptop or desktop, whatever you're using. And here we're focusing on doing things on this remote server that you started working with Friday, this Lambda server, and getting these techniques down like the shell and Vim, these things that you're going to need in order to use this remote server effectively. The main, I guess, cool project that we'll be doing on this remote server that you can't do on your own laptop is, again, analyzing all of the tweets sent from 2017, multiple terabytes of data. And so you'll need the power of this remote server in order to do this. This is also preparing you for if you're the data science major or just want to go on and take the big data class, CS143. The main idea of the big data class is that instead of using one remote server, we're going to be using sort of creating an army of potentially thousands of remote servers and coordinating them to solve a large-scale task. Actually, in the big data class, you end up re-implementing all of the backend services that Instagram uses. So you can create a service that scales up to the billions of users that Instagram has. And in order to do that, we need this material like the Lambda server, like this shell programming that we're going on over right now, and this Vim text editor. So that's why we're talking about these things so far. Yes, well, let's see. People often do computer science courses because they want high-paying jobs. If you go to this levels.fyi site, you can see roughly what starting salaries are for various companies. So Google's starting salary, $182,000. More the top end salary, if we click L8 right here, getting paid over $1 million a year. This is the highest one that they have published on this website. This would be somebody who's probably been at Google for 20 years or so. Other less famous companies making a little bit less, but still in that ballpark range. Things that you don't necessarily think about as students, first jobs, or our benefits. Benefits at these companies all really great. And this is true even though tech employers have been illegally colluding to reduce salaries. So if you want to, there's a Wikipedia article right near here if you want to learn more about how tech companies have been doing that. Okay, back to the course though. So who should take this course? Again, this is a second semester course, computer science, designed for students who have previously taken any of the intro programming courses anywhere at the 5 Cs. So I teach CS40, so it's mostly geared towards people who have taken CS40, but any of these other courses work. You cannot take this course if you've already taken a data structures course, so already taken a second semester course. Or if you're a CS major at MUD or Pomona. And again, this course required for the data science major and the computer science sequence, but it's optional for the data science sequence. The data science major is really who this course is designed for. And, but talking to you all, I'm excited. There's a handful of you doing these other things, and that's great as well. Any questions about anything so far? Okay, we'll get to more exciting stuff here in just a minute. I'm still going through the boilerplate-ish stuff. So learning objectives for this course, things we've already started here, this Linux terminal, Git, open source software. We're gonna be getting much more involved in all of these things. So we'll be having quizzes about this like bash programming and Git, going into much more advanced topics. All of your homeworks, again, you'll be using Git and GitHub to post them, doing things like just exactly following exactly what somebody at Facebook or Google or any of these companies would be doing. None of the stuff in this course is artificial. It's all the sort of stuff that these real world programmers are doing. This is all like the main focus programming wise. We'll also be talking a little bit more theoretical in this course. This is really the first course where you get into real computer science things, where we start combining math with programming. And so what we're going to eventually be talking about here in 2 weeks, once we get to the sort of foundation set, is if we're giving an algorithm, we want to be able to talk about, is the algorithm actually correct? Does it do what we want it to do? We'll be able to measure how many resources it consumes, so like how much time and memory or money it consumes, and we'll have to do a little bit of math related to our programming in order to do this. And we'll talk a little bit about proving if like there are no possible algorithms that can solve some problems. The class is called Data Structures and Algorithms for historical reasons. So some students see an algorithms course in the at other places or in the course catalog and thinks that this course overlaps with this. But this course is not at all related to what computer scientists think of as an algorithms course. This is a prerequisite for an algorithms course, and definitely recommend students who are interested in like the math stuff that we'll be talking about go on to take this graph algorithms course down here. This is normally taught by Professor Cannon, the other computer science person at CMC. But again, this is very much the getting into the math side of things. If you really like the math stuff that we talk about in this course, this is what you'd want to be going on. If you like the practical stuff, then CS 143 is what you'd want to go on to. Okay, the textbook. All of our textbooks, both free as in beer and free as in speech. So free as in beer meaning you don't have to pay for it. Free as in speech meaning that anybody can contribute to it. And so it's open source. And I've got some links right here, but the actual topics will reference whatever it is that you need for any particular topic. So you don't need to reference this. Just the important part here is that you don't have to pay for things. In the computer science world, we are pretty anti-money, and in the sense that we like things that are free as in speech and free as in beer. And so all the best resources are free. All the most recent up-to-date resources are free, and so that's what we'll be using. Okay, now we're going to get to important topic for multiple reasons. One is that everybody as a student wants to know, how are you going to be graded? What's your final grade going to be determined by? But we'll also get into the technical material about using this syllabus here with this grades right here. So I've got 5 different categories of things that will be part of your grade listed right here. All of these things, again, notice that their points are specified in this 2 raised to some power notation. So again, I want you to get familiar with how this notation works, these powers of 2, and by making all of your assignments use that many points, that'll force you to get comfortable with how big all of these numbers actually are. And you'll have the weekly labs, quizzes, projects, homeworks like you've seen already. And then here, item 4 right here, I have listed that we're going to have 4 exams, each worth 256 points each. I personally think that's a little bit excessive. And so if you think that's excessive, or you think anything on this syllabus is weird or dumb or you think should be changed, you have the power to go through and change it. And so we're going to walk through the steps right now of how you go through and change the syllabus. And we will change this line right here so that there are not going to be 4 exams worth 256 points each. In order to do that, it's a many-step process. And you should pull out this cheat sheet right here. That's the basic steps of a pull request cheat sheet. This is what we're going to be going over. We're going to be using this process right here to modify the syllabus and modify how your grades will be calculated in this course. So yeah, give you all a minute to get that pulled out. This process, so anything that involves the internet in any way is not something that can realistically be tested on a quiz, since quizzes are all pencil and paper. And so this process is not something that is going to be quizzed. You're not going to be quizzed on this process, but you will be forced in your labs and projects to go through this process. And we'll see that there's various extra credit opportunities from going through this process. So there's going to be a lot of steps from this process, but make sure that they all make sense and that you're able to reproduce it. The first time that you'll have to reproduce this is in the lab for this coming week, this Friday. In this picture right here, anything that is in this sort of cloud-looking shape is happens on the internet, the cloud representing the internet, and anything in this box right here representing the Lambda server, and then your laptop over here. And then each one of these steps, each one of these arrows is a step, and they're all numbered. And so we're going to start at step 1 over here. So fork. Up here at the top, I have the repository that I'm trying to modify. This repository is often called the upstream repository. And so it's for this class, the majority of the time, it will be github.com/mikeisbickies/something. Back over to here. We have github.com/mikeisbickies/csci046. And you'll press the fork button up here is step 1, forking the repository. This is, again, something that happens only on the internet, not something on the Lambda server. And we know that it's happening on the internet because it's between 2 cloud things like this. So fork right here. Press that, brings up this create new fork message, and you just press this green button down here. When you do this, it's a little bit hard to see in the URL, but the URL has changed. It's easier to see right here that we're no longer in mikeisbickies/CMC/CSCI046, but we're in currently logged in as CMC example student right here. So this is my GitHub account right here, CMC-example student. And it has this forked from message right here. If I click this, it'll go back to the original repository. At this page right here, there's no easy button listing where it's all the forks. There's 138 forks of this. If you wanted to click this, you could search through them all, but that's not the easiest way to find your particular version. If you go to your own homepage, just github.com/your user account name, all of your repositories will be listed here, including the ones that have been forked from other locations. So this repo 1 is just some repo that this account created by itself. And here over here, the CMC CSCI046 is the fork that I created. Clicking over here, back over here, and you can see that the contents of this repository are exactly the same. If we scrolled down here, we'd see all the same information on the syllabus that we were just talking about. In order to, so that's all that happens here in step 1, pressing that fork button. Step 2, in order to make a change to our contents now, we can't modify this original repository directly. We're going to be modifying our new forked repository. Here in this cloud down here, it says github.com/u/project, so that U is your user account. And we're going to be using the Lambda server, editing the contents of our files on the Lambda server, then putting that back onto our repository on the cloud over here. This repository that we have created, that we own, that is in our account, is often called the origin. So origin is the one that we own, and upstream is the one that somebody else owns. That fork step is the only thing that happens in the cloud on the internet. And so everything else, we're going to go to the Lambda server. And so we're going to open up a terminal window over here and connect to the Lambda server. Depending on how you connect, there's many ways, or what type of computer you have, there's many ways to connect. You can always go back to the email to get the information about what the IP address is and all that sort of information. If you're on any system where you're connecting through the terminal, the easiest way to connect, instead of going back, finding that email and copying and pasting it, is to use the terminal's history to get the command. You can use the up and down arrows to go back through your previous commands. And you see here, if I press up a couple times, I get back to this SSH command right here. And the CSCI 046 example is the account name that I have on the Lambda server that I'm going to connect with. If you don't want to press the up arrow, or the up arrow down arrow is taking too much time, there's another shortcut, Control-R, which lets you search through your history. And if you type in your username, CSCI 046, as soon as it'll find whatever the previous command is that has this piece of information in it. This is what I typed in, and it searches through your history to find that. So that's what we get right here. And I just hit enter. It asks me to connect. I type in my password. I type in my password correctly, and I'm connected. Throughout all of these classes, again, I think I've mentioned this before, but I'm going to be talking about various tricks for using the terminal efficiently, like using the up arrows and this Control-R to search through your terminal history and other things like this. None of those things are things that you are required to learn, but they are things that will make your use of the terminal more efficient. I'm never going to test you on what does the up arrow do when you're in the terminal, but when you will be in the terminal for a little bit more than 100 hours in this course. And so learning about these shortcuts will make you a lot more efficient and make things easier for you. So don't worry about trying to memorize all those things. Just try to absorb as much as you can, and that'll be good for us. Again, last time we talked about this ls command. The ls tells you what is in the current folder you're in. We also talked about the cd command. CD standing for change directory. Directory is a synonym for a folder. And I'm going to go into the proj folder right here that we created this last time and type ls again. And currently we have nothing in my proj folder right here. I like to organize all of my accounts on all of the machines that I'm using by creating a proj folder and putting all of the GitHub repositories that I'm going to be working with inside of this proj folder. Again, yeah, for various historical reasons, computer programmers don't like typing out full words, but prefer doing just individual syllables when possible. And so proj is probably more common than the full word project when people are working on things. In order to actually acquire the project, to download it from the internet, if we come back to our cheat sheet right here, this step 2 right here says git clone. We have to git clone is the process of going from the internet onto the Lambda server. Coming back over here, if I type git clone, and then I type the URL that I want to copy from the Lambda server. The URL should be the URL of the main page of the repository. So it's the one, it should end in whatever the repository's name is and have your username right before that. If you click on one of these, so it's, again, the URL up here is hard maybe to see. I can't really make that part bigger. But if I click on one of these, you can just see that the URL gets bigger over here. That's not what you want. You want to make sure that you can click on the name of the repository right here. So you're in the main page of your repository and copy and paste that URL. Copy and paste that over here, and like that. It'll look something like this for you, but your user account will be different. It'll be https://github.com/your user account name /CMC CSCI 046. And here, again, notice that my GitHub account username is different than my Lambda server username. And it's very easy to get confused about those two things. That's just something that you want to always be aware of what I'm using. Am I using the GitHub account or the Lambda server account? Really, the only time you're using the Lambda server account is when you run this first SSH command to log in. Anytime you're using a command that has Git inside of it, or you're working on the internet, then you'll be using your GitHub account over here. I'll go ahead and press enter right here. And you can see that this is the output that I have so far. And if I type ls right here, we can see that nothing happened, or there's no new files in this folder. If we look closely at this output down here, we can see that there are, at the very end down here, we get these fatal messages that these errors happened. And it's not like highlighted in red for us in any way. All of these tools that we're using generally expect the user to actually read through all of the things carefully. That output does not get printed to the screen unless it's extremely important. And so it's generally expected that people read through the output of everything. And down here, you see that there's this fatal, means like a really bad thing happened. And at this point, we don't need to understand exactly what the bad thing was, but because there was this fatal error, nothing actually happened. It didn't download anything. In order to fix this, there's a number of ways to fix this, but I'm going to highlight really quickly that you'll notice here I'm in the forked version of this repository, and there are no issues or pull requests or anything opened in this forked version of the repository. But if I go back to the main version of the repository over here and click issues right here, and then there's this first issue, git clone fails on Lambda, that Nolan was already going through these steps and noticed that when he ran this clone command that it failed. And this is an excellent job of posting this sort of information to the issues so that everybody has access to it or to ask questions. It's all formatted really well, and it provides us a good solution down here on how to fix the problem. So there are other ways to fix the problem, but since this one is already posted, we'll use this. Copy that right here and come over to here. Run that, git config -- global pack.threads1. And again, I just copied and pasted that from the GitHub issue. Hit enter. And now if I press the up arrow to go back to my previous git clone command and hit enter, we can see that the output over here is very similar to the output that we had before, but there is no fatal colon down here. So we don't have these two lines right here. And so now if I type ls, then we have this folder. The name of the folder that we just got is going to match exactly the name of the repository that we were working with on GitHub. And I can cd into that folder right here and type ls. And all of these contents, all of these files down here that we see, these match exactly the contents of the files that are on GitHub. I'm going to pause here for a second. And any questions about anything so far? Yes. Yeah, so the question is going into a little bit more detail about what exactly the problem was and what exactly we did to fix it. The short answer again is that this line right here is just something to copy and paste into your terminal, and that will fix it. A more detailed answer is that the reason we were getting those error messages is that your accounts on the Lambda server have a lot of limitations built into them. One of those limitations is that you're limited in the ways that you can do parallel programming. And the reason for that is so that you don't accidentally do something that uses up all the resources on the Lambda server and makes it so that other people can't use it. And so this right here disables Git using parallel stuff and allows it to actually continue to work. The details of that aren't important. The important thing is just that you take that and that you run it. I'm gonna modify this issue here for a second though, just so we can see some ways to improve this writing and make that more clear about what exactly is the thing here that you have to do to fix this. You'll notice right now I'm logged in. I'm not logged in as my normal user account. I'm logged in as the CMC example student account. And so when I press this 3 buttons up here, these are the only 2 options that I have, this copy link and this quote reply. I'm going to come over here for a second, though, to now in this other Firefox window, I'm logged in as my actual normal user account, the user account that owns this repository. And there we go. Now, when I press these buttons up here, whoever owns the repository has the ability to edit all the messages. And I'm going to make some minor edits here just to highlight some formatting things that make things clear. The first formatting thing, so again, anytime you're making edits in GitHub issues, you can always press this preview button over here to see what the final edits are going to look like. But the first formatting thing is that anytime you have a command that is been run into the terminal, it's a good idea to put this $sign at the front of it so that people know what are the commands. Just at a glance, we know what are commands that have been typed in and what are outputs of various commands. So this down here was the output of commands, contains this fatal right here. It does not have the $sign in front of it. This right here does have the $sign in front of it. That lets me know that this was something that I typed into the terminal and it resulted in this error message down here. Press the preview, and you can see that it has these $signs down here. Makes it a little bit more clear that down here, this is the thing that you type in to fix, and it's not part of the error message. Also, it's a little bit weird to just start off a GitHub issue with some code that has been run, and it'd be good to just have a nice little sentence up here saying, when I run this command, and then just to make it grammatical, it throws the following error on the Lambda server. Update that comment. And now this is the just slightly better, makes it a little bit easier again to know what's the command and what's not the command. Let's come back over to our cheat sheet now, and we'll just review what we've done so far. Again, the fork command, the thing on the web page was this first number 1. Now I've run this git clone over here, this number 2, going from here over to the Lambda server. This next step, step 3, editing things on the Lambda server. In this step, we're going to change the files to be whatever we want them to be. And it's always a 3-step procedure anytime you do that. So this first one is you use Vim to modify the file. Then the second one says git add and then git commit. So you want to work through this procedure a little bit on the lab. Again, it's okay if it's not 100% second nature, this procedure yet, but definitely we're going to be doing this like every day for the next semester. So by the end of this course, this should all be automatic for you. Down here, so here in my, this whole long prompt thing that I have over here, this is the path that I'm currently in. This tilde right here refers to my home folder. So tilde/proj/cmcic 46, that is the path that I'm currently in. If I type pwd, I can get another version of that where the tilde has been expanded into this full home folder right here. But the important part here again is the end, that I'm in the project cmccsci046 folder. And so I can always know that I'm working inside of which project, whatever project I'm in, by looking at the folder right here. And the very last one over here matches the repository that I want to edit, so that's good. This thing in purple right here is the current branch that I'm working on. And this branch right here, 2023 spring, that's the branch for our current semester. This same repository has been used at CMC for 3 different courses. And so there's 3 different branches corresponding to each version of those courses. We want to modify the one for our semester though, so we want this branch. And so it's good that that was the default. I want to edit the README file, so I'm going to type vim space README. And again, I am super lazy. I do not want to type out all of that README. That's a great path towards carpal tunnel syndrome. So I just type R and then press tab, and it does it for me. And very nice. And I hit enter. Now here is the contents of that README file. Again, when I want to exit Vim, :Q will exit. And when I want to enter, I can just rerun that same command again. We know this is a markdown file because it ends in .md. Every repository will have some form of a README file. It's common to have a README file like this that is just plain text without the .md. It's also common to have the readme.md. Other extensions, less common for README files. But every repository is going to have a README file. And then here's all the markdown for the that generates that that GitHub HTML page. Come back here, come back to our, going back to my forked repository right now, and we want to figure out what is the code that I want to have changed. I wanted to come to this grades again. I wanted to change the grades. And in particular, I wanted to change this item down here, this thing about 4 exams. So I could like, I don't know, scroll down all the way through here and try to figure out like where in all this source code is that 4 exams. But that would take a long time and we don't have all day. We are lazy people. Hopefully you'll get more lazy as the semester goes on. Probably all of your other professors say the opposite, but they are wrong. You should get more lazy. In order to be properly lazy, in order to be efficient, in order to do things well, we can search in Vim. And the shortcut for searching is the / key, the /. On an American keyboard, it is the one that is to the left of the shift key and not the one that is above the enter key. So I press the /. It is again below the question mark, the one in the bottom right of your keyboard. And now you can see down here in the bottom left, I'm in this search mode. I know I'm in search mode because it has the / down here in the bottom left. / is a super common hotkey for representing search. If you're in Firefox even and you press the / button, then you'll search the web page that you're in. But any terminal application that allows search, it's always going to be / that allows search. And what I want to search for is the thing that I want to modify. So here, 4 exams right here. I'm going to search for 4 exams. So / the number 4. There's a lot of number 4s, space, and all I had to do is do 4 space, and it took me down to this line. 4 exams worth 2 to the 8th points each. Hit enter and it takes me back to normal mode, and now I can edit things. If I wanted to edit this, well, I do want to edit this, but there are many ways to edit this. Sort of the most naive way to edit this is to press I to go into insert mode and then use the delete key to delete all these things one at a time. But this is not thinking like a Vim person. This is not thinking like somebody who uses the terminal. This is thinking like somebody who uses VS Code. And so I'm not going to do this. I'm going to press escape to get back into normal mode. I'm going to press U to undo what I just did. And I'm going to delete this whole line in just 2 keystrokes. I'm going to press C, C standing for change. And then I'm going to press the $, C $. $, stands for the end of the line. And so when I press C $, it deletes everything from where my cursor currently is to the end of the line and puts me in insert mode. You can see down here in the bottom left, I'm currently in insert mode. And now I can type and say, no exams, like that. Press escape, and with, I don't know, 10 keystrokes, I did what in VS Code would have taken either a complicated mouse movement or like 100 keystrokes. Again, on the lectures, anytime I'm doing something in Vim, I'm going to be saying out loud what I'm doing so that you get some sense about what these different hotkeys are, and try to incorporate them in your own editing of text files. But this thing that I just talked about of using C $, so what I did was C and then $, that 2 keystroke combination is in the Vim tutor tutorial. It's also in the Vim cheat sheet that I gave you all. And so spending time working through that tutorial again, most people need to complete it more than once to fully like absorb everything inside of it, will be very, very useful for you as you go forward in this class. The other things that I want to change here is, so I have this little thing right here commented out right now. This is an HTML comment right here. And I want to delete that HTML comment and re-add this line right here to our README file. So this is saying that non-seniors, and actually we should change that to non, and so what I did right here, so, okay, let me walk through everything. So I accidentally pressed U to undo what I did. I pressed Control R to redo what I did, down arrow twice to come to this line. I want to change this word right here, seniors. So I'm going to press F, S. F stands for find, then S is the letter that I'm trying to find. FS jumps me to the letter that I'm trying to find right here. And I want to delete this word. Again, I want to also enter insert mode. So I'm going to use the C command, C for change. It'll delete whatever I'm working with and go into insert mode. I want to delete just this word, not the entire line now. So I'll do CE, CE. E takes the cursor from where it currently is to the end of the current word. So now non-graduating students, escape. So again, that up here I used $C$ to delete to the end of the line, CE to delete to the end of the word. And I'm going to, so the reason I was doing this, non-graduating students will have to complete a final project due during finals week. Graduating students, your grades are due earlier than that, so you get out of this final project. I want to delete these comments now, delete 99 and 101, these lines. And the easiest way in Vim to delete a line is you press the lowercase d button twice in a row, dd, deletes the line. Down one, dd, deletes the line. And now we've edited this file, made the changes that we want. Again, if the Vim things are seeming complicated, that's okay. You will get, by the end of the semester, familiar with all those things, but practice will be good for you. And again, you don't have to memorize all the things that I'm saying in class. Just try to absorb as much of those tips as you can. This next one, the important thing, exit and save Vim, :WQ, save and exit. And now we have successfully modified that README file. We have completed over here this very first step of step 3. We've just done Vim in the file, changed it to whatever we want it to do. Anytime we're modifying something in a Git repository, not only do we have to save the file, we have to tell Git that we want those saved changes to be added to the repository. Again, if I run git status right here, we can see that in red are the files that we have saved or modified in Vim, but not added to the Git repository. Up here that we say that these changes are not staged for commit because they are not in the staging area. In order to add something to the staging area, it's git add readme.md. Now, if I run git status, this is in fact in the staging area. Git status is one of these idempotent commands, so you can always run it, and it will never modify the state of the Lambda server. And so it's always a safe thing to run to debug, just to get a better understanding of what's going on. Now it's in green because these changes are staged to commit. We say these changes are in the staging area. After running git add, we run git commit, and then I'll add this -m of updated. Actually, we'll do remove exams. This -m says that whatever comes after it is the commit message, a short summary of what are the changes that we've made. So git commit -m, hit enter, and we get this sort of summary right here. If I run git status again, then we see that there's nothing in the staging area, no files that have been modified that are not committed yet. So we're good to upload our contents to GitHub. If I come back over to the cheat sheets, again, these commands right here, Vim, git add, git commit. These are the 3 things that you need to do to complete step 3. Yes. I'm going to pause you for a second. The question is more complicated than we are prepared to answer at this point. So it's a good question. Happy to answer it after class, but not yet. What we need to do next, we've made changes on the Lambda server. We need to get those changes from the Lambda server up to GitHub. And we're not going directly to the upstream repository, not going directly to the course syllabus. Instead, we're going to this origin or downstream repository that we forked, that we created. And the command that we'll use for this is git push origin, and then master over here is, let me type it out right here, git push origin. This first thing right here is the name of the repository that we are pushing to. So this one right here is origin because we are pushing, where did it go? There it is. We're pushing from the Lambda server to the origin repository. So git push origin. This fourth thing over here is the name of the branch that we're using. Master is the default branch in Git. There's, in certain situations, the default branch has been changed to main, but we'll talk about those details later when we've covered the material necessary. The important thing is that this third thing right here is the name of the repository that you're pushing to. vast majority of times will be origin. This fourth thing over here, vast majority of times will be master, but currently, since we're editing the CS46 branch, or the CS46 repository, it has no master branch. The branch that we're editing is 2023 spring. That's what we will put over here. Whatever your terminal says right here is what you'll want to have right here, and that'll work all the time. So git push origin 2023 spring. I hit enter, and it asks me for my login credentials to GitHub. And this is a little bit confusing. So I'm going to start by typing my actual login credentials to GitHub, and we'll see what happens. So CMC-example student. Again, this is my GitHub account right here, not my Lambda server account, my GitHub account. I hit enter, and I'm not going to tell you what my password is, but I promise I'm typing in my correct password right now. And you can see down here that we get these error messages about support for password authentication was removed. Your error message might look a little bit different, but you're going to get an error message. It's not going to work. In order to run this git push command from the terminal, we have to go through a couple extra steps that GitHub has added for various complicated security reasons, but we'll go through those steps right now, and so you can see how to do this. Any page that you're on, we'll just go to a random page over here. Any page that you're on when your account, you have this top right button up here, and if you click that, the very bottom thing over here above sign out will be settings. We'll click that. What we're doing is we're generating something called a personal access token, and that is what we'll be using as our password when we connect to GitHub. So again, on the top right over here, I clicked that and clicked on settings. Then on this left-hand column over here at the very bottom is developer settings. So I started up here, going down to settings, then the left-hand column at the very bottom, it said developer settings, and now we're going to personal access tokens. And we're going to be doing classic personal access tokens. And then up here, so you click, personal access tokens, tokens classic, and then generate new token. I'm going to run through all those steps one more time, just in case you missed one of them. So up here in the top right, click that, go down to settings. You get to your settings page, scroll down to the bottom of the settings page. The very bottom thing is developer settings. You click that. And then under personal access tokens, we want the classic personal access token. Up here in the right area, it says generate new token. That's what we'll click. And we want the general use, for general use, generate new classic token right here. These other tokens, you could use them, but they just have more complicated options for more fine-grained security, so not important for this class. The classic tokens will be the easiest to use. You press that. It asks you for your login password again. And so I have Firefox stored my password for me. Password managers are just generally recommended for good security practices. Especially for things like GitHub that maybe you don't want to dedicate space in your brain for a good password. But once you do that, you get to this page right here, new personal access token. You want to make sure you change this expiration so that it has no expiration, so that you'll be able to use this personal access token throughout the entire course. And down here, all this, these are the various privileges that you're allowed to do with this personal access token. The things that will be important are that you can modify repos, this one here, and this workflow button. You could click all the other ones too, but I don't think we're going to be using any of those other options in this class, so you don't have to. Again, it's the top two, this repo and this workflow that you need. And after you do that, come down and press generate token. Yes. Yeah, it requires that you put a note up here. Doesn't matter, just say something like created for class. And press the generate token. And when you do that, you're going to get a big, long password like this. And so one of the reasons that GitHub uses these personal access tokens is that people being fallible and don't generate good passwords, but machines do know how to generate good, strong passwords that not even the NSA knows how to crack. And so that is an example of a good, strong password that nobody can crack. But do not leave this page. This password, this personal access token, will never be given to you again. It is impossible to get access to this token here from the GitHub webpage. So what you want to do, you need to copy this string, and then you need to paste it into a text editor somewhere and save it somewhere where you're going to have access to this in the future. I'm going to put this on, since we're already logged into my Lambda server over here. I'm going to put this in my Lambda server, and I'm not going to put this in my current repository. I'm going to put this in my home folder. So I'm going to type cd right here to go to my home folder. And then I'm going to use vim to open up a new file. I call my personal access token files pats, vim pat, and hit enter. And now I'm going to paste this, this string into this file right here so that I'll have access to this password forever in the future. In order to paste into Vim, if I try just pasting right now, then all of these commands or all of these letters would be interpreted as commands in normal mode. And so it would do a bunch of weird, strange things and not really type it in. So I'll just go ahead and do that just to see what happens. Oh, I guess it did type it in. The very first command happened to be one that enters things. But you can, in general, always press I, go into insert mode, and once you're in insert mode, paste, and then things will work well for you. If you're on a Mac or anything that's not Windows, then you can just paste using your normal pasting features of your operating system. If you're on Windows, in order to paste into PuTTY, right-clicking will paste whatever is currently on the clipboard into the PuTTY window. So I press escape :WQ to save that. And now I have access. If ever I need my personal access token again, I have access to it right there. And where to go over here. Now it is safe for me to close this page because I'm not going to need this access token anymore. Again, once I close this page, it is impossible to get access to this personal access token, to this password. And so only close it after you're sure you're already saved that file somewhere. Reopen this. Again, this is the line right here where we have changed so far. Notice that even though I've made those changes on the Lambda server, if I come over here on GitHub and refresh this page a couple times, those changes are not taking effect. In order for those changes to take effect, we have to complete this step right here, moving things, pushing things from the Lambda server on to GitHub, this git push origin master. We tried running that command, but we failed because we did not have the personal access token. So now, we're going to rerun this command using the actual personal access token. In order to rerun this command, let's see what happens first. I'm going to press the up arrow to rerun this command right here, but I'm in the wrong folder right now. I'm in my home folder right here, not in my project folder. And so if I rerun this command, we're going to get this fatal error message that Git is not in a Git repository. Again, we know we're in a Git repository because if I run ls-a, there would be a .git folder. There is no .git folder, so I'm not in a Git repository. In order to change my folder, I'm going to do cd project/cmci csci046 like this and hit enter. And I changed my folder like that. It's good practice to try to change, make this folder try to do it in one step, to go cd project/cmci046 if you can, but it's also okay. So if I'm back in my home folder, type ls, okay, there's this project folder, cd proj, ls, okay, now cd cmci046. Either one of those results in the same final state, but this is a good one to get in the practice of, save you time, and when you're working with people, the more experienced people will be just expecting this sort of one command. When one command can work instead of 4 commands, they'll be expecting these like one command things. So not necessary to combine it all into one command, but try to get into that habit. Okay, now we're ready to run the actual git push command down here. Git push origin 2023 spring. I hit enter. We do not get the error message about not being in a Git repository because we are in a Git repository. We ran the Git clone. It created that Git repository for us. Now I type in my username again from GitHub, CMC-example, student, like that. And now I need to type in my personal access token. I have already forgotten what my personal access token was. I mean, how stupid of me to not remember those 30 random characters. So I need to open up that file that contains that personal access token and enter it in. Well, right now, I am currently inside of this, this git push menu, so I can't I mean, I could leave this Git push menu and get access to it. But instead of that, I'm just going to real quick open up another terminal window. I happen to have hotkeys on my computer to get access to terminal windows. And so I just open this one real quick. I will use the Control R to go back to my my SSH command right here. I searched for my username. There it is. I hit enter. I log in. There's my password. And now here, I'll open up my personal access token file. And now I have it right here. I'll copy that and paste it right down there like that. And now I logged in. And no error messages down here. No error messages down here. If your final thing ends with a line that looks like this, then everything works. And if we go back over to GitHub now, I can press refresh right here. And now we have successfully changed the syllabus so that it says that there are no exams in this course. And that is the correct thing. There won't be any exams. There will just be these quizzes and projects that will form the main part of your grade. It's a good time to come up for air and see if there's any questions about anything. Yes. Yeah, so the way the copy and pasting is working is going to be different for everybody's computer. If you are on a Windows machine using PuTTY, then anything that you highlight in a terminal window will automatically be sent to the clipboard. And any time that you right-click, it will automatically paste. If you're on a different machine, then it will be, yeah, it depends on your particular system settings. And so if you can't get the pasting feature to work, then don't try to type that whole thing out by hand. Just see me after class and we'll figure out how to paste. But good question. Yes. So the question is, can you use more fine-grained tokens? You're welcome to you're welcome to do whatever procedure you would like, makes sense for you. You don't even have to store the personal access token on the Lambda server if you don't want. Feel free to store it on your laptop. But yes, as long as you're able to push to GitHub, then whatever you do is good. The important thing is that there are ways to sort of short circuit this process and do editing of things only through GitHub, but you are not allowed to do that in this course. Anytime that you are editing something that is on GitHub, you will have to bring it down to the Lambda server and edit things on the Lambda server, going through this git clone and git push process. The very last step for us, though, is that we have changed this project down here. We've changed the origin project, but we have not changed the upstream project at all. Back over in Firefox over here. So here, this web page has the changes made to it right here. If we scroll up to the very top of this web page, we'll see that I'm still in the CMC example student repository. And if I click right here, and scroll down to that same spot, those changes have not been updated to this upstream repository. I own this upstream repository, so you don't have direct permissions to edit this. You have to request that I accept your edits. So that request is called a pull request, and these pull requests happen through the GitHub interface. They always change their interface, but I think if we click here, yes, so currently I'm on the forked repository again, CMC example student, CSCI 046. And then right here, it tells me how many commits I have done that are not in the upstream repository. I am one commit ahead of the upstream repository because I've made one change to the README file. If I press this contribute right here, open pull request, then it will ask whoever owns the upstream repository to add those commits, to add those changes. And so here, this little message that it shows right here by default is whatever your commit message was. If you needed to add more explanation, you can add that right here. But we'll just go ahead and press this green create pull request button right here. Create pull request. And now if we come over back, we're on the main repository right here, the original upstream repository. Click the pull requests and So yeah, a lot of people have added it. Let's come down to mine right here. And here is the details of this pull request. I'm not logged in right now on this Firefox window as the owner of this, so I don't have permission to contribute to this pull request or to accept this pull request yet. But right here, anybody can look at what the details of this pull request are. This again is the hash of the pull request. If you click this, then it will show you what is called the diff of the pull request. And the stuff in red right here is the old text. The stuff in green right here is the new text that has been added. This is maybe looking a little bit similar to the merge conflict things, where there was old and new. And that's, if that is ringing a bell, then that should, because it's a very, very similar process. But this screen right here is called the diff, showing the difference between the original and the new version of the file. In order to actually accept this file, I'm going to come back over to my Firefox window that has me logged in as me. Click on the pull request tab and come down over here. And now I have access to this merge pull request button, confirm merge. And now we officially have no exams in this course. Let's come back over here and let's finish real quick talking about the rest of the things. So no exams. Occasional extra credits, we'll talk about that a little bit as they come up. You can look at that now if you'd like to. Just a quick note, historically, the sort of typical student needs to spend about 10 hours per week outside of class in order to get an A in this class. There's just a lot of material in this class. It's a hard class, and so it takes a lot of time. Some students will choose to spend either more time than that and get an A out of class, or spend 10 hours or less and get a lower grade. And that's just typically how things work out. For late work, again, all penalties, everything in this class in this exponential 2 to the whatever power. So if you're just, this I right here is the number of days late. And so if you are just a few days late, just 1 day late, it's the penalty is basically negligible, just 1 point. But because it's exponential growth right here, the penalty will grow very, very fast. And so we'll be talking a lot about exponential growth of our algorithms in this class. And again, this will get you some intuitive intuition about that concept. Grade schedule. Let's see, we'll talk about those things later. I just want to make sure we talk about this academic integrity policy today. So technology policies. You must, all assignments on this in this course, do them all on the Lambda server, not on your own personal computer. Must be logged into the Lambda server whenever you're working. And you must use either Vim to edit a file, or there's this other program called Emacs. If you happen to use that, you're welcome to use that. But you cannot, in particular, use like things like VS Code or Idle or PyCharm or the GitHub text editor or any of these other things that you might have used in previous classes. And in particular, some of you may have submitted GitHub pull requests through the GitHub interface previously. You are not allowed to do that in this course from now on, and you must go through this process that we just went through to edit things on the Lambda server. We'll be getting to points in this course where we'll be doing more advanced editing of files and collaborating with other students, and it's impossible to do those more advanced things through the GitHub interface. And so I want you to be getting into the proper habits of using the command line for these things. Last thing, you cannot share your Lambda server credentials with anybody else or have anybody else logged in as on your Lambda server account. And so any of these technology things, they might not seem necessarily like academic integrity violations, like copying somebody's work or something like that. But all of these things up here will be treated as academic integrity violations if you break these. Collaboration policy as well. So there are no restrictions on what you can post to GitHub issues. Students are often shy about posting too much code to GitHub issues, but you should not be. You are highly encouraged to post lots of detailed questions involving lots of code to GitHub issues. That's what it's for, so please do that. You're also highly encouraged to collaborate with students in these 3 scenarios, so in class and lab, in the QCL, and in office hours. That most students find that collaboration is going to be very effective for learning the material. So I really want to encourage that. But in order to ensure that the collaboration is done in a good, healthy way, this course is going to be different than, say, CS40 was, or other courses that you might have had with me, if you've had them with me. You cannot work with another student unless you are in one of these three settings. So I want to encourage collaboration. You can collaborate however is effective for you, but you have to be in one of these three settings, either in class lab, at the QCL, or in office hours to collaborate with another student. Also, all of the projects in this class, they'll be posted on GitHub, so it is trivial to find other students' code and to see exactly what they did and to copy and paste their code and submit it. But you are not allowed to do that. You are not allowed to look at another student's repository on GitHub. And I want to make that a social policy and not a technical policy. I don't want to make these things private because I want you all to be able to show these off to future employers. And I want you all to be getting into these habits of developing open source software so that after you're done with this course, you'll be able to do all those things well. And then very last thing down here, accommodations, lots of things in the course designed to be very accommodating. For example, the quiz, again, reminder, quiz on Wednesday. Anybody can come and get extra time on the quiz if you feel like that would benefit you. But if there's anything else that I can do to make things accommodating, please let me know. Technically, we have a homework that's due tomorrow. We've covered everything that you need for the homework. But there will be no late penalty on this first homework assignment. So if for whatever reason you can't get it done before tomorrow, then don't worry about that. You'll be able to ask questions or at a later point. I see a handful of hands. We're going to end class here, though. If you still have questions, I'll stick around as long as people have questions, and we'll get those questions answered. But this is our official end of class, and I will, again, see you all Wednesday with the quiz.